This video is on what I'm calling section 9.k notes. This is where I'm starting to bring it back to the beginning of the chapter in the book, where we start to learn about matrices and systems of equations. But I'm not doing section 9.1 quite yet, especially not the way that it's written. What I did is I took information from a few different sections and compiled it into these notes. To kind of pre-teach a little bit of content that will help make section 9.1, I think, a little bit easier to learn. So we're going to learn how to use matrices to solve systems of equations, kind of the traditional way first, the easier way first. So first example says to use matrix multiplication to write the system of equations in terms of x and y. And so they gave you these matrices, these two that have been multiplied together. Here is the resulting matrix. And if you look at these matrices, we have a 2 by 2 matrix on the left, and then a 2 by 1 matrix. And so we know that we can multiply them because the 2's match, and that our resulting matrix is going to be a 2 by 1 matrix, and so it fits that this could be our answer. So if we multiply these together, I'm just going to take my left finger and go across each row. I'm going to take my right finger and go down each column as I multiply these. And so what I'm going to get first is 3x and then 2y. So 3x plus 2y is the first entry in my 2 by 1 matrix. Okay, and then the second entry is going to be 4x plus a negative y, or 4x minus y. And so this is our 2 by 1 matrix, and we know already that it equals 1, negative 6 on the right side. And so these two matrices are equivalent. They're both 2 by 1 matrices. And so now I can say 3x plus 2y is equal to 1, and 4x minus y is equal to negative 6. So we can see this is how we would start with a matrix and write it as a system of equations. And we can also do the reverse. They're saying here to write the following system as an equivalent matrix equation in the form A times x equals b. And so this is what they mean. This is matrix A, this is x, this is b. So they'll call A the coefficient matrix. These are all the coefficients, x the variables, and then B is the matrix with the constants. So coefficient matrix, constant matrix, and then the variable matrix. So here we'll have our coefficients. So 2, 1, 1, negative 1. And then our variables we'll write as x, y. And then our constants, 5, 4. And you can always double check to make sure if you were to multiply those out, you would get back to the original. But 2x plus y would be the first line, which equals 5. And then for the second line, we would have x minus y, which equals 4. All right, so now that we know how to take the system of equations and write a matrix, or take a matrix and write it as a system of equations, we want to see how we could actually solve this system using matrices. So this is just kind of a symbolic representation where we don't have to write down the matrix for each piece, but we can just see what we're going to do to move the matrices around. So this is matrix A, the coefficients. So this is our coefficient matrix. The x's are the variable matrix, and then B is the constant matrix. Okay, so what they have us do first is we want to get our variable alone, so we need to get rid of A. So to get rid of A, you have to do the opposite of A, or you have to do the inverse of A, which is what we had learned how to do in the section 9.4 notes. So we're going to take the inverse of A, and we're going to multiply by the inverse. So over here, A inverse times A, those two kind of cancel out, but we know that when we multiply them together, A inverse times A, we end up getting the identity matrix, that 1, 0, 0, 1 matrix. That's what we end up getting. Now, whatever we do to the left side of the equation, we have to do to the right side of the equation. And if you notice, they're being very careful here. They multiplied the A inverse matrix on the left side of this multiplication here. And so they're doing the same thing when they do it to the right side of the equation. They're putting the A inverse to the left of matrix B. And the reason they're doing that is because we've learned in this chapter that the order you multiply things in matrix multiplication, the order that you multiply matters. So whichever order we do the multiplication, we have to keep it consistent between the left side of the equation and the right side of the equation. So here we multiplied by the A inverse matrix on the left so that it would be right next to the regular matrix A, and so it would cancel out. And so since we multiplied A inverse on the left side on this equation, on this part of the equation, we have to do the left side on this part of the equation as well. All right, so A inverse times A gives you the identity matrix, and we know that the identity matrix multiplied by the variable matrix, that anything times the identity is just going to be itself. So when we multiply that, we're just going to get the variable matrix. And then on the right side, we can go through and we're just going to take that A inverse and B, and we're going to multiply it. And when we do, we're going to get some answer. We're going to get two values there, and we're going to end up with the variables equal some answer, and that's going to be the solution to the system. All right, so let's go ahead and let's do this with a problem so that we can see how it works. So I'm going to start off by writing this system out as AX equals B. So 2, -3, 1, 1, X, Y, 1, 8. Okay, so here we have AX equals B. Okay, so the next thing that we need to do is we need to find A inverse so that we can multiply A inverse times A. So A inverse, the first thing we need to do is find the determinant. So the determinant is these two multiplied together, 2 times 1 is 2, minus these two multiplied together, so minus -3. So the determinant is 5. And then to find the inverse, we take 1 divided by the determinant. We take these two, the 2 and the 1, and we swap them. So we're going to have 1 and 2. And then for these two, we change their signs. So -1, +3. And then we go through and we just take this 1/5 and we distribute to all 4 of those numbers. So our inverse is going to be 1/5, 3/5, -1/5, 2/5. Okay, so what we're going to do now is we're going to take this A inverse and we're going to multiply it on the left side of the left side of the equation and the left side of the right side of the equation. So we're doing this step right here. So I'm going to take A inverse, 1, 5, -1, 5, 3, 5, 2, 5, and multiply it by A. I'm also going to write this on the left side of B. Okay. So now I'm going to go through and I'm going to multiply these out. And I'll go ahead and write down what I've done. A inverse times A times X, A inverse times B. Okay, so if I multiply these out, nothing's going to multiply by the variable matrix because I can only multiply two matrices at a time. So I'm going to have 2/5 plus 3/5. So this is my row 1, column 1 position. 2/5 plus 3/5 gives me 5/5, and that's just 1. All right, next I'm in row 1, column 2. So negative 3/5, positive 3/5. That gives me 0. Okay, over here, negative, so now I'm in row 2, column 1, down here. Negative 2/5, positive 2/5 gives me 0. And now positive 3/5, positive 2/5. Positive 3/5, positive 2/5. That's 5/5, that's 1. All right, so I've ended up with the identity matrix multiplied by X. Okay, now over here, I'm going to multiply A inverse times B. So I have a 2 by 2 matrix multiplied by a 2 by 1 matrix. 2 by 2, 2 by 1. So I can see, yes, I can multiply these, and a 2 by 1 matrix is going to be my answer. Okay, and my answer, I'm just going to call this A inverse times B because that's what it is. All right, so 1/5 and 3/5 times 8 would be 3/5 times 8 is like 3 over 5 times 8 over 1. So this is 1/5 plus 24/5. 1/5 plus 24/5 is 25/5. So 25/5 is what I can write. Okay, more on that in a second. And then for the next one, we've got negative 1/5, and then 2/5 times 8. So negative 1/5 and 16/5. Negative 1/5 and 16/5 gives me 15/5. So I can simplify this. I can say that 25/5 is 5 and 15/5 is 3. All right, now we can do this multiplication right here. We know that the identity times any matrix is itself. So when I multiply these two together, I'm just going to get xy. I'm just going to get the variable matrix. And we can see that x plus nothing is just x. Nothing plus y is just y. So here we have just the variable matrix equals these two numbers. So we have x, y equals 5, 3. And so our answer for that system is, or our solution to that system is the 0.53. That's our solution. So what you'll notice is to solve this entire system, you can show all of your work. You can show the start. I had the coefficient matrix times the variable matrix equals the constant matrix, and I can show all my work here. But in reality, the most important piece, the piece that gets me to my answer, is that the variable matrix equals the inverse matrix times matrix B. So if we're looking for a formula, the formula to solve a system is the variable matrix equals the inverse of the coefficient matrix times the constant matrix. This is your formula. If we're showing all of our work, this is all of our work. All right, so when you're doing this on MyMathLab and you're practicing, I would practice it both ways depending on how your professor or your instructor is going to be asking you on your test. So if I were asking you to show all of your work, I'd want to see all of this. This would be all of your work to solve the system using a matrix. If I don't say show all your work, then you can show it just by doing the variable matrix equals the inverse matrix times the constant matrix. Showing this would be using matrices to show your work. It just doesn't show all of it. Okay, so practice both of them. It's good to know exactly what you did here, but it's also kind of good to know that this is a little formula you can use, and it can be pretty quick to solve a system. Definitely quicker than doing it by hand normally.